Hello, another in the series of DIY solar. We're going to be doing more things in the future. Subscribe if you want to see some of the ones in the past. Coming up projects are the dual converter driving a GTI from grid tie panels, and we also have a PowerPoint water heater controller. But right now I'm looking at the 130 amp power meters that you can get on eBay. This blue one in a metal case, you can find this one as cheap as $8. And there's two problems with them, and that is they only go up to 60 volts, and sometimes the displays are awfully hard to read. I have to go in with a flashlight sometimes and hit it at an angle. That can be corrected by adding a contrast pot. As you can see, you can go from one extreme to the other, and there's a perfect setting somewhere in there, and 50 millivolts will change it from a pretty poor reading to a good one. So it's worth doing if you can't read it. This is what the schematic of what you have to do. The first three pins of this 1602 display, the first pin is common, second one is 3.3 volts, and the third one drives the visual display. I just use a 10K pot and a 1.2K series resistor, and that does the trick. It's easy to hide sometimes in the case, or just figure out what a fixed voltage setting is and sub in a resistor. Now for the higher voltage, you can use the power pins at the side if you want to run this thing off battery, so you have backup power when your main source is not working. You can use this power pin. It's the center pin, and you can connect that to your voltage source. And what I've done with my units is, if you open them up in the back, there's a single, like 3/4 inch trace that's in the middle of a ground plane. It's easy to find. If you cut that connects the red wire from the sense voltage to the power regulator. And if you just cut that, then the only power source will be this pin here. And on this I put a voltage divider, 680K to 100K, with a 10K adjustment pot, and that gets me a 10:1 ratio. So this one is reading 1.77 volts, and I'm feeding 17.7 volts in. This display is off. It's not really accurate, but I mean it's spot on when you adjust it right. And so it just takes two resistors and a small pot. Only one of the red wires needs to be connected. Now, what I suggest is when you power these externally, if you're doing over 60 volts or 50 volts, you can just use a cell phone wall wart that produces 5 volts. This is a 3.3 volt system, so as long as you have 5 volts or more, it'll run fine. And otherwise, I suggest putting in a resistor to do voltage dropping instead of dropping the heat in the linear regulator. 220 ohms for a 12 volt system, 1K for a 24 volt, and a 2K for a 36 volt. Now sometimes these are rated at 130 amps, but don't put more than 30 amps in them. One of the things I found when looking on the internet is that the hobby people actually say that the wires to the current sensor actually overheat and disconnect with a lot of current. And I have one of these in a system where I measure up to 100 amps, and I use a 100 amp current shunt and connect it to the two black wires. And in that system it gave me like an 8.6 to 1 ratio. Adding a couple inches of wire to the leads going to the shunt will give you enough extra resistance that if you have a 10 or 15 volt, 10 or 15 amp calibration system, you can make the current also in a 10 to 1. So the math is pretty easy. All you have to do is multiply the number you see by 10, and the watts or the volts or the amps, and you'll have the real numbers. That's my tip for today. Thanks for watching.